Hello, welcome to my channel. On this video, I will show you how to solve numerical problems on one-way ANOVA. Let's look at the challenge we have on the board. 15 petri dishes containing certain strain of bacterium are divided into 3 sets of experimental groups of 5 each. Into the first set, no antibiotic was added. Into the second set, antibiotic A was added. And into the third set, antibiotic B was added. The data are counted colonies after the end of a first period. Test whether the results suggest that there is a difference in the colony count between the 3 sets. Take the level of significance to be 5%. Please include one mean comparison test. The table here shows the 3 sets of data. In set 1, no antibiotic was added. Set 2, antibiotic A was added. In set 3, antibiotic B was added. Create a column for the square of each of the sets. So we've created a column for the square of each of the sets. Each of the sets contains 5 samples. 1, 2, 3, 4, 5. We record the n value to be 5 for each of the sets. This step says sum each set. 243 plus this plus this plus this, lastly plus this. We have 1325. Next, 198 plus this plus this plus this, lastly plus this. 200 plus this plus this plus this, and lastly plus 215. The next step is to get the square of each of these values. Square of 243, 59049, 312 square. Square of this. Follow that process to fill up the remaining spaces here. Add all these values together. 59049 plus this plus this plus this, lastly plus this gives 359581. We also get the square of each of these values here. 198 square, 39204, 187 square. Square of this. We also follow the procedure to fill up the remaining spaces here. Add all these values. 39204 plus 34969 plus this, lastly plus this, 202334. Now we'll proceed to getting the square of each of these values. 200 square gives this, 176 square, 250 square. We'll follow this route to fill out the remaining spaces here. Add up all these values. 40,000 plus this, lastly plus this gives. Now we'll calculate the mean for the first set. The mean will be this value divided by this value gives 265. Mean for this set will be 996 divided by 5 gives. Mean for this set will be this value divided by 5 gives 206.6. Now we square the sum of each set and divide by n. For the first set, 1325 square gives this, divide by 5, 351125. Next we have 996 square divided by 5 gives this value. For the last set we have 1033 square divided by 5 gives this value here. This step says sum all the sums. That implies addition of all these sums. Adding the summation of all the s together. We represent that with this symbol, sum of sums. This value plus this value plus this value gives 3354. Adding up the sum of squares together, we represent that with this symbol here. We have this value plus this value plus this value, 778480. Now summing the values of these together, we represent that with this symbol here. So we have this value plus this value gives 762946. State the hypothesis. The first hypothesis is the null hypothesis, presented with H naught. What this hypothesis is saying is that the mean colony count of bacterium on the 3 sets are equal. Symbolically, the population mean in set 1 is equals population mean in set 2, also equal the population mean in set 3. The alternative hypothesis, represented with HA, says that the mean colony count of bacterium on the 3 sets are not all equal. This step says determine the total observation. Remember we have 3 sets of data, set 1, 2, and 3, right? And each set contains 5 samples. Therefore, our total observation will be 3 times 5, which is 15. So we record that here. Capital N represents the total number of observations. This step says calculate total degree of freedom. Total degree of freedom is represented with TDF and the formula is m-1. Remember, our m value will get 15 minus 1, which is 14. We also record this in our ANOVA summary table. Total degree of freedom, 14. Calculate the degree of freedom of the sets. To represent that with SDF equal, remember we have 3 sets, right? Minus 1. 3 minus 1. 2. Set degree of freedom. 2. Calculate error degree of freedom. Error degree of freedom is equal total degree of freedom minus set degree of freedom, which will get 2. 14 minus 2. We'll also record this in our ANOVA summary table. Error degree of freedom, 12. Calculate correction factor, CF. To calculate correction factor, we take the square of this value here, divide by this value here. The square of this gives this value over 15. They divide by 15. So our CF value is calculate total sum of squares. Total sum of squares equal this value here minus value of correction factor. This minus this gives, right, total sum of squares. Calculate set sum of squares. Set sum of square will be equal this value here minus value of correction factor gives, right, set sum of squares. Calculate error sum of squares. Error sum of square equal total sum of square minus set sum of square. Error sum of square. Calculate set mean of squares. Set mean of square equal set sum of square divide by set degree of freedom gives this value. Set mean of square. Calculate error mean of squares. Error mean of square equal error sum of square divide by error degree of freedom. Error mean of squares. Calculate F value. F value is set mean of squares divide by error mean of square gives 5.012. Check for F critical on the F table. This is our ANOVA table. The level of significance given to us is 5%, which is equivalent to 0.05. Set degree of freedom, remember, we got 2, and our degree of freedom of error, we got 12. And so we trace this to 12. Our F critical will be 3.89. We also record this value on the summary table. Right. Accept or reject null. So HO is rejected because the F value is greater than the F critical. Conclusion. Our conclusion will be based on the fact that we rejected null. So for the fact we rejected null, we accept what the alternative hypothesis is saying. An alternative hypothesis says that the mean colony count of bacteria on the 3 sets are not all equal. The next question says, please include one mean comparison test. Basically, mean comparison test is used when null hypothesis is rejected. Please stay tuned for the next video where we demonstrate how to include one mean comparison test. I hope this video is helpful to everyone. Please do well to like this video, leave a comment, share, and subscribe to my channel. Thanks so much for watching. Bye.